Yo, assalamu alaikum wa rahmatullahi wa barakatuh. Yo, guys, welcome back to another live stream. How are you all guys doing? Oh, I forgot I have no viewers right now. Bye. Forgot it. My bad. I forgot about it. Yo, see my eye? This is me. Totality. Hey.
Hiyo, hayo, totality, hayo.
बचपाती मजमक से सारे लोग मैं हूँ totality heal. This is me, guys. Welcome back to another channel. Welcome back to another channel. My bad. Welcome back to another live stream. Today we are gonna do some physics numericals, just like our Robert W practicing accounts. You know what? Let me put as live here so that you guys can see. My guy is literally studying. Oh my god, man. So what we'll be doing here is exactly we're gonna open this. I'm gonna put the window capture on. Guys, can you see it? You know what? Let's do this. Alright, let's go. Now let's put it in a black color so that can you see me? Can you see his cam? What the hell is this wrong with this cam, bro? Like, dude, why is it always lagging like this? I do not like that at all. Oh, what? Yo, what? My cam isn't working now. What the hell? Keep putting it back here. Okay. No way. What's going on? My cam ain't working anymore. What the hell? Yo, my cam ain't working. What's going on? I cannot enable my cam now. Like, really, what the hell? What is going on exactly? What if I put it here? Oh, okay, wait, guys. Let's go. Finally. Uh-oh. Can you guys see me? You know what? Let's put this back down. Oh my god, this cam. Oh god, again stuck. I hate this. just said it so randomly. You know what? Wait a minute, guys. This cam is a bit awkward. I'm gonna bring my phone stand. Just wait. बुला रही हैं।
हाँ आ रही हूँ आ रही हूँ
एडिट करे
मुझे नहीं मालूम
क्या मान है लाइव चल रहा है
हाँ
बुला रही नहीं
अच्छा आ रही हूँ
कर ले कोई और चुप रहो
क्या बोल रहे हो
This girl is so irritating, I swear. Like, dude, if you don't know, she messes with me so bad, like, I swear. My sister has got some really good genes of my father's, man. Like, dude, oh my god. For sure, my camera got stuck. For on God, my camera got stuck. I just wanted to set up the camera, that's it. Oh my god, this girl. What the hell is this, dude? She broke my cam. Wait a minute. Oh, my cam is literally broken. This ain't working now. Wait a minute. I got an idea. Let's connect it here. Then fix this port. Alright. Then if we do this, 3, 2, 1, bam! We should be getting it. Oh my god, my webcam. Whew. I want to check how I'm gonna like do this. So this method, okay, this one looks fine, right? Yeah, it kind of looks great. I want to somehow keep escape of how I'm actually doing it. So, wait a minute. Yo. Oh, finally, dude. Okay. I hope this time doesn't get stuck. When it's studio tour, this is my laptop. You can see. Hi. Say hi. Oh yeah, my laptop. Look at the jiggling. And then this is me. And this is my bag. I always take out the whole stuff. Then this is my bed. I sleep here. And that's it. A very small studio tour, huh? Yep. Because this studio tour you see is not my actual studio. I don't even have a studio. That's the thing. No? Remember, I don't have any studio. I have to use this, so okay. So we'll take out our physics here. Okay. I wanna somehow adjust this cam. Like, how am I gonna use this to actually apply here? This looks fun. Now what is going on, dude? Like, how should I exactly like put this up here? Should be lifting in it. The frame should be somewhere here, where people can see me what I write. Okay. But what? This is much worse. Like, dude, how can I exactly adjust this thing? Like, can you guys see what I'm writing? Let's see if we can read this. 2. Oh, my handwriting is already bad, so this is not going to be easy at all. Try reading this. Rigid body. What is this? Rotational system of particles in rotational motion. Let's take a random word. Let's say this one. Rotational motion, in which all the particles of a body moves with the same velocity, irrespective of their distances from the axis of rotation. Means it is readable, but then the thing is, it's very blurry. It is readable, but it's very blurry. Okay, this is not gonna be easy at all. I don't know how to fix this part. How am I gonna even put the webcam here? Like, already the cam is not working that well. Wait, what? Alright. Let's see. Yep, this looks fine. Let's put it a bit more deep. Now, finally, dude. Okay. Whoa, no. That kind of leaks everything. Yo, can you read what's there? No, you cannot. I guess it's very far away from it. So, I feel like this is fine. This is really fine. I can make it much. Okay, let's put this at this corner. And let's start the challenge now. I don't want to waste any more time. We're gonna do our challenge, and let's start off with it. Okay. So let's start off with numericals. Of course, we're gonna do numericals. we still have some numericals left for this chapter. Alright. Yo. Let's start. Do you guys want me to put the timer too? I hope this is capable. Yes, timer, please. Timer. Okay. Let's go. Oh no, I don't want to delete timer. Let's put this and put this in. Now wait a minute. I'm gonna put the timer. All right. Oopsies. Guys, let's put some friction. And then we're gonna put this. Right. So, alright, you're gonna do physics, right, huh? Do you mind checking your this, because I think your stream was lagging a bit. That's why. There is no atmosphere in moon. Please tell me why. The reason why we don't see any atmosphere in the moon, it's because the gas particles used to be there, of course, but the thing here was the escape velocity of moon is much lesser than that of the escape velocity of Earth. You see, the escape velocity of moon is in fact much lesser than the thermal velocity. The thermal velocity of gas particles are exhibited in them, and therefore they have much greater in it. So they can actually exit out into out from the moon, and therefore they have the moon does not have any atmosphere. But then why does the moon have very less escape speed? Why does it have this kind of thing? You see, if we look at the equation of the escape speed, we need to see that the mass of the moon and radius is much smaller than that of the acceleration due to gravity. Stop trolling, and please do not put that here, because I don't want you to come back here again and start trolling. Please do not put this. No, stop. Oh my god, I swear. Like, dude, I have to wash my hands. I have to eat this afterwards.
ASMR. ASMR is so bad.
Stop.
His ASMR is so bad.
Let's go. Oh my god, this isn't working. So escape velocity of moon. Why? Because of the mass and the radius of the moon. Yeah, there is another reason. If you know the formula of small g, it is given as g is equal to capital G capital M r square, right? Yes, it is given by that. So gr square is equal to gm. Yes, it indeed is. So therefore, can we say that small g is equal to capital G capital M? Yes. Gr square is equal to gm. Now, let me explain you something. Physics is having some kinds of trust we need to know. When we look at the escape velocity, let's look at the escape velocity, okay? What's the escape speed? Root 2 gm by r. Alright. Can I take the value of g in the form of gm by r square? Yes, you do. Then I can substitute and I get gr square is equal to gm. Right? Yes. So I get this as 2gr square by r. Right? Yep. I cut these both, then I get root of 2gr, and that's how I actually get the value here. So it depends upon the g too, actually. Then the escape velocity of moon is actually, you know how much? It's actually 2.5 kilometers per second. It may look great, but remember that the escape velocity of Earth is much bigger. Like it's 11.2 kilometers per second. And what is the orbital velocity of the Earth? It's 7.92 kilometer per second. That's the one thing we need to know. We need to have an idea based on that. All right. Okay. Now let's do one question. There's a question, okay? It says if 400 kg of satellite is in a circular of radius, okay? So the mass is 400 kg of circular of radius 2 re. All right. So 2 re to 4 re. That's the radius of the Earth. So it's 2 times the radius of the Earth to the 4 times of the radius of Earth. All right. Right, he is locked in, dudes. I'm so sorry. He's very locked in. Okay. Wait a minute. So, mass is 400 kg. 2 RE to 4 RE. Not Ferrari, not Ferrari, dude, huh? What are you thinking of? So, it's a circle. So, there is a 400 kg satellite. It's revolving around a planet. Of course, a planet. And then, of radius 2 RE above the Earth. How much is the energy required to transfer it to the circular orbit of radius of 4 RE? So suppose I say that I want to find out the amount exactly, the amount. So from our, what will be the energy exactly what I need? So and if we actually apply some logic, because physics is more logical here, it says I'm gonna put 4 RE minus 2 RE. That's gonna be 2 RE, of course. So we need to just find out what is the amount of energy. You see, this is 2 RE. This is the orbit, that is 4 RE. He's just telling me to find this remaining path, and this remaining path is just 2 RE. So that's why I took 2 RE here. Okay, I did not talk about the total one. Alright. So that's a fact actually you need to know. 2 RE. Now, what is the formula of having of the orbit of the satellite having energy when it orbits the planet? So the energy is basically the total energy. Okay. Oh yeah, you guys want the desktop audio to be there? Let's put the desktop audio, guys. You guys can hear me now, loud and clear, and you can also hear his voice. Energy is minus gm small m by 2 RE. Alright, this is the one. Now, this is gonna be the new energy, so I'm gonna take E dash minus gm m small m by 2 dash, so this is gonna be 2 RE dash. Okay, so this is gonna be minus gm small m by 2 into 2 RE. That is gonna be minus gm and 2 RE into again 2. This is 1 by 2. That is E dash is equal to E by 2. So that's the thing. Also, yeah, I get it. I got the energy. It's fine. It's easy. You don't have to like go for much deeper in that basis. It's very easy to find out the value. All right. So Yeah, let's go for another numerical because we need to actually like get some really great level of numericals. Okay. Hmm. Also, I accidentally missed one derivation, and we have to go through that derivation too. So after we complete this numerical, we're gonna go through that derivation. All right, guys. Where is it, guys? Oh damn, where is it? I cannot see that, man. What the hell? Where is it? Yo, where is it? Huh? I just cannot find it. Yeah, this derivation. Yo, man. Oh, shoot. Let's redo this question number 12. Because question number 12 is really the next level. Also, I may have to do some questions again where I wasn't able to. Like, suppose. Oh, yeah, this question. I wasn't able to do this question. So, what is this question exactly describing? Question number 9. A force exerts an impulse or J on a body, changing its speed. So there is an impulse, and impulse we know the formula F into delta T. That is the amount of force applied in that short amount of time. That is impulse. The force and the motion of the object is in the same direction, okay? Meaning that you can literally say F dot F vector dot S vector. That is, I just got the idea. I'm not copying, I swear. Fs cos 0, meaning that this is Fs. Because wherever there is motion, there will be some distance or displacement getting covered, right? That's why. I just got the idea. Also, I got the idea of work done because I saw the formula, and the formula gives work done. And we have to actually prove that work done is basically equal to J into U plus V by 2. So what do we have to prove here? We have to prove this equation. W is equal to J into U plus V by 2. This is the one. Got it? This is the one. Yep, alright. Oh dad, why is it connected? Oh, finally. Now I might have to not worry about this. Let's go, guys. Let's continue, okay? So, what do we exactly have to prove here? W is equal to J into U plus V by 2, okay? W is equal to J. Now we know J here, and I can apply. Let's understand what we need to exactly do here. Alright. Can we say that force is equal to ma? Of course you can say that. I consider that there is a constant uniform acceleration, so 2as is equal to v square minus u square, okay? Because I got u and v here, that's what I'm thinking of, you know? So 2as is equal to v minus u is equal to u plus v. That's what I feel like, huh? By 2, and this 2 gets me 4as divided by v minus u. Now this method is a whole lot of different, but I'm just thinking of solving it practically. That's why. Or I can do this. Take f as. This time I took f. So f is ma, of course. S, what is s? S is v square minus u square. So sorry, s is v square minus u square by 2a. Cutting this off, what do we get? We get m into v square minus u square, and I can put this m v into minus u into v plus u divided by 2. Now m v minus mu into m v plus u by 2. Now this mv minus mu is basically change in. Man, why does this happen? Why is this happening though? What? Okay, let's go. He pinned it. If many people like him, then he has to do a lot of push-ups. You guys agree to that? Anyways, you know what? Let's not waste time again. Oh, my bad, my bad, my bad, my bad, my bad. Let's do this question. This question is really next level. Okay. Suppose we are doing a physics practical. Okay. Okay. Suppose we are doing physics practical this time. We have a plane here, and this plane, another plane that is going downwards here. Okay. Suppose it is connected to a pulley. Okay. This is connected to my pulley. When will you make videos? I'm just saying this. Okay. Suppose this is a spring. Alright. Now, this is good. Okay. Anyways, this is a pulley. Now this pulley, he actually has an idea. Yep.
Yeah. After this exams get over, right? You'll like start a series of filling the whole syllabus. So you will start like as about morning and then they'll continue that for next 2 months.
Alright. So this is a spring. This is a really great question actually. I like this question. There is a spring here, and it is connected to a string or any kind of thread, you know. Then this there is a frictionless pulley here, and then there is a block of mass 1 kg. Now, if I apply Newton's laws of motion or the friction concept from the Newton's laws of motion chapter, what I can get here is that this side there is R that is acting here. Then also this is mg. Okay, there is mg here, and here I'm gonna actually put this down first here. Okay, this is gonna be another one, and I'm gonna vector resolve this. So this is having an angle. What is the angle here? This is the angle of inclination or the angle of repose. By this I put another theorem, and I get mg cos theta and mg sin theta. That is finding here the weight overall. So we have an idea right now. Yes, we really do have an idea. Oh, what the hell, bro? Chill. Ow, bro. Don't do this. Okay. Anyways, now this is one thing we need to have an idea based on it. Okay, so F here, the force that is acting here is also acting in the form of restoring force. Okay, this force is acting in the form of a restoring force. What else is given is, I guess there's an extra thing. Yeah, the K value. Hooke's laws, the spring constant is given, that is 100 Newton per meter, meaning that we need to apply 100 Newton of force to actually have an extension of 1 meter of a spring. So that is gonna be our F extent of restoring now. Now, how do we exactly find this? We have to get an idea based on that. Yes, we really do need to get an idea. First of all, what I'm gonna do, okay, also they gave us the distance, right? Do they? Yeah, they had given us the distance, and the distance they covered is 10 centimeters. That is 0.1 meter. And F restoring, we need to find that. We don't know. Suppose I want to find force, so I'm gonna do one one formula that is given from the derivation of the 4th chapter of physics. That is mg into x sine theta plus mu x cos theta. This is a formula that we studied long back in our fourth chapter of physics. This is a very interesting part here right now. The mass is 1 kg, of course. Let's say that our g value is 10 meter per second square. Because I want my calculations to be easy, so 10 meter per second square. All right. Now x, what is x? I think it's 0.1. X is 0.1. We can also take the value of x as common too. Yeah, we can do that too. So let's do that. You know what? F is equal to mgx. Okay, x value is 0.1 meters because it's basically distance. I forgot about that. Now mgx is equal to sine theta plus mu cos theta. What do we exactly have to find here? That's what the question needs to give us. So we're basically finding the coefficient of the kinetic friction, because this is the object that displaces, that moves. So this is going to be coefficient of kinetic friction, and we need to find that. Now mass is 1 kg, gravitational acceleration due to gravity is 10 dot 0.1 into sine theta. Now sine theta and mu k cos theta, we don't know the value of theta here. That is the thing. We have no idea about the value of theta. But from this formula, what can we apply here so that we get the formula of this thing? Can we first take this 1.010, okay, dot here 0.1, that is gonna give me here the sine theta plus mu cos theta, right? Okay, that is here, of course, and then we take here, this is gonna be 1 sine theta plus mu cos theta. Now that's the only thing that is left, mu cos theta. Just imagine this, okay? Also, yeah, wait a minute, I forgot to tell you this. This is energy, by the way. This is energy stored. So let's say that sine theta plus mu cos theta is half kx square. Is it? Yes, it is. K, what is K value? 100 Newton per meter. What is the value of K? 100 Newton per meter. So sine theta plus mu cos theta into half of 100 into x square, that is 0.01. That is going to be sine theta plus mu cos theta is equal to this multiply. Why did I take half kx square? Because this is the potential energy of an elastic potential energy of a spring, of a helical spring, we could say. This is half. Now suppose, okay, let's consider that value of theta is 37. Why should we consider value of theta being 37? Now it will give us an equation. I think it should be given. I don't know why they did not give this in this question. They should be giving it here. This is something really wrong here. Like, there is something going on with this question. Anyways, it's fine, you know, it's not gonna be that bad, of course, but we are capable of finding. We can take any value of theta actually. By taking any value of the theta here, we will get the value of mu s. Okay? We are gonna get the value of mu s with the help of that, because sine 37 and cos 37 will be alternate values, and they will give you the same result if you had done that with other angles too. Suppose I say sine 60 minus mu cos 30, or just say sine 60 minus cos 30. What will that be? Is this gonna be root 3 by 2? Yes. This is gonna be 1 by 2. Yes, this is gonna be root 3 minus 1 by 2. That's the thing here. Different value. Oh, sorry, my bad. Why do I make these kinds of mistakes? My bad. This is cos 60. Okay, 1 by 2. So yeah, there is an idea based on this. So theta 37, sine theta, I mean suppose I say sine 37 plus mu cos 37 is equal to, what is sine 37 here? Let's draw a triangle, a right angle triangle that has angle of 37. Okay, always remember that angle 37 degrees, the Pythagorean triplet of this right angle triangle will always be 3, 4 and 5, and that is the same case for an angle for 53 degrees in that right angle triangle. Why is 37 and 53 considered famous? Because if you get the trigonometry ratios of these angles, you get exactly that number. Like sine 37 is 3 by 5. What is mu k? Okay, mu k into cos 37 is 4 by 5 is equal to 1 by 2. Now what I do here is, suppose I want to find the mu k value, right? So I take this here. No wait, 3 plus mu k 4. Let's do that. By 5 is equal to 1 by 2. 3 plus 4 mu k is equal to 5 by 2. Now I take this 3 right there, so it's gonna be 4 mu k here, and then 5 by 2 minus 3. Then okay, wait, so we're gonna solve this. So it's gonna be 5 by no, there's something wrong here. What is it? It's gonna be minus 1 by 2. Okay, minus 1 by 2. So mu k here, that is 4 2 is 8, minus 1 by 8, and that is minus 0.125. What Newton? No, not Newton per meter, my bad. Since this is coefficient of static friction, there is no unit because it's force by force, so there is no unit. Alright. Oh yeah, there is a small change, there is a small error in the formula. That shouldn't be the thing here, so yep. Anyways, here it's gonna be this. This question is really good. Next level question. Let's do gravitation numericals. The gravitation numericals, they are top notch, so we gotta do them as fast as possible. Or we gotta solve the one derivation too. Also, how do we find the orbital velocity? I did not mention that, so we gotta check that too. So yep. Okay, let's start. Very easy question. First question. A body weighs, see, that question was a bit struggling for me because of course I'm still a newbie for physics. I'm not that great at all. I'm not a PhD. I did not do PhD in physics. What's going on? It looks like my camera's stuck. No, it doesn't. How's it possible? Yeah, what is going on, guys? Yep. Here we go, guys. You can see his channel now. Can you? Yes, you can see his channel. You really can see his channel now. Now let's start off with the first question. The first question says that the body weighs 63 Newton on the surface of the earth. So let's say the weight is 63 Newton. Alright. Okay. Then what is the gravitational force on it due to the earth at a height equal to half of the radius of earth? If h is r by 2, what will be the gravitational force? So let's first of all know that we are basically talking about force here, 63 Newton. What is the formula of force? That is actually about gravitational force mainly. That is mg. Remember that, mg. Okay, so mg is the force that is acting, and that's the main idea we need to have. Why is it off the road? Here we go. I want to ask him something. Wait a minute. He's locked in. Let's not disturb him then.
Sure, ask me. Yeah,
Hmm?
टी शर्ट बदलिया ना करियो कैसा था मैं मैथ्स पेपर
alhamdulillah अच्छा
हाँ
अच्छा
इजी था पूरा करिया एक भी मिस करिया नहीं
78.5 आती
17
8.5 आती
17 है 78 80 को
right. This is Earth. R is 1.5 into 10 raised to 8 kilometer. You stop that, dude. Don't do that. Like, dude, why is it doing this? Still don't understand. What do you exactly want me to find? The weight of the sun. To find MS now. Let me think about this. What? R is 1.5 to 10 raised to 8 kilometers. So, what is going on? Oh no. this is our, we have to find the mass of the sun. So how do we do that? First of all, we will apply Kepler's third law. T square is equal to r, is directly proportional to r cube, right? Yes, it is. Let's say that we need to find the mass of the sun. So how do we do that exactly? Can we say that T square is equal to GMS by 4 pi square? Or no, wait. No, this is 4 pi square. Arrow! 4 pi square GMS into r cube. This is the equation, I guess. T square is equal to 4 pi square GMS into r cube. Now what is r cube given? We'll check this out later. We need to find the mass of the sun. So how do we do that exactly? Need to check 4 pi square, so 4 into 3.14 the whole square divided by 6.67 into 10 raised to minus 11 into mass of the sun, we don't know, r cube 1.5 into 10 raised to minus 10 raised to 8 kilometer. Alright, there's another one, wait a minute, there's another one. How do we find the time period though? That's the main thing we need to talk. Alright, orbital velocity is gm by r. So yes, Haru. gr square. We don't know the r square value though. We may know the g value. Think about it. T square is equal to 4 pi square in divided by GMS into r cube. How do we do this? You know what? I have an idea. 2 into 2 pi T square is equal to 4 pi square divided by GMS by R. Hmm. 4 pi square R divided by GMS. This is gonna be pi square R G R square. Alright. this really requires log. So ten into r square 6.4 into 10 raised to I feel like it, yeah. The orbital velocity formula is this one itself. Couldn't be any other formula, right? If it could have been that, then it could be different. 12 square. थोड़ा पढ़ ले को अच्छा फिर आप We need this. Let's go. जाओ जाओ लैपटॉप के पास क्यों नहीं दिखाओ लैपटॉप के पास क्यों पानी है 12, 10, 17, 15, 17, 1.7720, 7720, 6.4, right? Log of 64. Two is a 4, 2 6 a 12, Wait a minute, guys, I will come back. I have to end the stream, sadly.